Assalamu alaikum doctors, welcome to my YouTube channel MBBS and BDS lectures. Today is the 9th video of repeat revision course of Periodontics, which is very important for NLE, MDS, NBD as well as for BDS students. In this video we will discuss about calculus. In 8th video we already discussed about dental plaque. Now today we will discuss about calculus, its types and difference between these types, and composition of calculus, formation steps of calculus, and different mineralization theories and anti-calculus agent. Now first, what is calculus? Actually, when plaque become mineralized, it is known as calculus. Now there are two types of calculus. Number one is the supragingival calculus, which present above the gingiva. Which present above the gingiva is the supragingival calculus. Second is the subgingival calculus, which present below the gingiva. Now what is the difference between supragingival calculus and subgingival? First, the supragingival calculus color is white or whitish yellow, but subgingival calculus color is dark brown or greenish black. The second difference is supragingival calculus is hard clay-like consistency, but subgingival calculus is a hard flint-like consistency, and flint is the types of stone. Third, supragingival calculus is easily detachable, but subgingival calculus is firmly attached to the tooth. Next, supragingival calculus are more common lingually in lower incisor and buccally in upper first molars. When we see patient with calculus, the calculus will be more deposited in the lower teeth incisors areas, lingually and incisor teeth, and most of the time in upper first molar. The buccal surface of upper first molar is completely covered by calculus. Next, the source of supragingival calculus is the saliva, but the source of subgingival calculus is the GCF, mean gingival clavicular fluid, and we are already discussed GCF in detail in our previous videos. Now next, these are the differences between supragingival and subgingival calculus. Now come to the more differences of subgingival calculus from supragingival. Like in subgingival calculus, its location, visibility, color, consistency, attachment, common site of deposition, source of mineral, formation type, all are different. Next, in subgingival calculus, we will discuss in next slides. There is a different crystal form which are formed during calcification of plaque. One crystal form is the white locite. Second is the brucite and octa calcium phosphate. Now here in subgingival calculus, the magnesium white locite is greater than supragingival calculus. Meaning subgingival calculus, the magnesium white locite crystalline form is more present as compared to supragingival calculus. This is MCQ's point. Second, brucite and octa calcium phosphate crystalline form is less present in subgingival calculus as compared to supragingival. Mean in subgingival calculus, the most abundant crystalline form is the magnesium white locate, but in supragingival is the brucite and octacalcium phosphate. Third, the ratio of calcium to phosphate is greater in subgingival calculus as compared to supragingival calculus. These three differences are very, very important. Mean the supragingival and subgingival calculus differences are very, very important for MCQs, like its color, its consistency, its attachment, its source, its crystalline form, and its ratio of calcium to phosphate. Now come to the composition of calculus. In composition of calculus, there is calculus is composed of inorganic constituent and organic constituent. In inorganic constituent, which is in 100%, it is the 70 to 90%, but organic constitute the remaining 10 to 30%. Now, in inorganic constituent, in 70 to 90%, in inorganic constituent, calcium phosphate is 75.9% and calcium carbonate is 3.1%, and remaining is the magnesium phosphate, sodium, zinc, and fluoride. Now, in inorganic constituent, the crystalline form are 4 types of crystalline form. 4 main crystals are present in crystalline form. Hydroxyapatite crystal constitute 58%. Mean the most common type of crystalline form is the hydroxyapatite, which is 58%. Then magnesium white locite, which is 21%. Magnesium white locite is 21%, and third is the octacalcium phosphate, which is 12%, and brucite is 9%. These percentages are also important because in crystalline form, the most abundant is the hydroxyapatite, which is 58%, then magnesium white locite, then octacalcium phosphate, and then brucite. Now we already discussed the white locite, magnesium white locite are abundant in subgingival calculus, and octacalcium phosphate is most abundant in the supragingival calculus. Now come to the organic constituent, which is 10 to 30%. Here in organic constituent, there is a protein, polysaccharide complexes, desquamated epithelial cell, leukocyte, microorganism, and lipids. Now come to the attachment to the tooth surface. How calculus attach to the tooth surface? There are 4 modes of attachment, 4 ways of attachment. Number 1 is the attachment by means of organic pellicle, because first pellicle is found due to salivary protein, then when microorganism come and colonize in the pellicle, then this is known as plaque. When plaque calcified, this is known as calculus. This is the one method, attachment by means of organic pellicle. Second mode of attachment of calculus is the mechanical locking into surface irregularities of the teeth. There are surface irregularities, there will be mechanical locking. Third is the close adaptation, mean closely present to the tooth structure. Close adaptation of calculus under surface depression to the gently sloping modes of the unaltered cementum surface, mean closely adapted to the unaltered cementum surface. The fourth method is the penetration of calculus bacteria into cementum, which is known as calculocementum, mean when calculus formed on cementum surface and the calculus bacteria penetrate into the cementum, this is known as calculocementum. Again is important. These are the four modes of attachment. Number one is by organic vehicle, second mechanical interlocking, third close adaptation, and fourth penetration of bacteria. Now come to the formation of calculus. How calculus formed. Now, when plaque formed, then plaque undergo mineralization. In the result, there will be calculus formation. Now, how occur precipitation of mineral salt in the plaque? In plaque, the mineral salt will be start to precipitate out. In the result, there will be hardening of plaque to become calculus. Now, these points are very, very important for MCQ's point. In plaque, in plaque, start between mean precipitation of mineral salt in plaque start between 1st to 14 days of plaque formation. When plaque formation occur in from 1st to 14 days of plaque formation, the mineral salt start to precipitate out. But calcification are reported as early as 4 to 8 hours of plaque. Mean when plaque deposit in 4 to 8 hours of plaque, the calcification will be start. Mean from 1st to 14 days. Now, the 50% mineralization occur a plaque in 2 days because start from first days to 14. In first 2 days, 50% mineralization of plaque occur and 60 to 90% occur in the remaining 12 days. Mean 12 plus 2 is a 14 days because the plaque calcification occur from 1st to 14 days to become calculus. Now, all plaque does not undergo calcification. All plaque does not undergo calcification. Microorganisms are not essential in calculus formation because in plaque formation, the microorganism, primary colonizer, secondary colonizer are important, but in calculus formation, it is not essential. Next, the source of mineralization in supragingival plaque is the saliva. In subgingival plaque, calculus is the gingival clavicular fluid. Now, the calcification began along the inner surface. The spherate foci of calcification increase in size and coalesce mean fuse to form solid masses of calculus. Formed and the calcification the calcification occur in layer. Formed in layer open separated by thin cuticle which is embedded in calculus as a calcification progress. Now, on the basis of calculus formation, in some people there is a heavy calculus formation, in some moderate, in some light. Therefore, there are three types of calculus former people. One is heavy farmers, calculus farmers, second is the moderate, and third is the slight calculus farmers. Now, again remember, these are very, very important. Maximum calculus formation mean the maximum calculus formation occur from 10th week to 6th week month. From 10th weeks to 6th month, in this duration there is a maximum calculus formation. But after that, after 6 months, again the calculus formation will be decreased. Why? And this process is known as reversal phenomena. Why? Because due to when it formed in 10 weeks to 6 months maximum, then the calculus start breakdown. Why? Due to friction, due to wear. Calculus occur due to food, due to tongue, due to cheeks, due to muscle friction. The wear of calculus occur, the calculus start breakdown and again decrease. Now the main points is that, and this process is known as reversal phenomena, which occur after 6 months. Now here in formation of calculus, the most important points are the calculus formation start in first to 14 days of plaque formation, and the calcification are reported early as 4 to 8 hours on first day, and 50% mineralization occur in 2 days, and 60 to 90 occur in remaining 12 days. Next is the source is saliva and GCF. Next, on the basis of calculus formation, there are heavy, moderate, and slight calculus formers. Maximum calculus formation takes 10 weeks to 6 months, and after 6 months, again the calculus formation decrease, which is known as a reversal phenomena. Now come to the theories of mineralization. How mineralization occur? There are basically 4 theories. How plaque mineralization occur to become calculus? There are 4 theories. Number 1 is the booster mechanism. Second is the epitectic concept or heterogeneous nucleation concept. These theories are very, very important. The third is the second is the first is the booster mechanism, and second is the epitectic concept, and third is the inhibition theory, and fourth is the transformation theory. These are the 4 theories of mineralization. First is the booster mechanism. In booster mechanism, mineral precipitation results from a local rise in degree of saturation of calcium and phosphate. When calcium and phosphate are saturated, when concentration of calcium and phosphate rise locally in local area, in saliva, in GCF, in result there will be mineral precipitation start, there will be calculus formation. Second theory is the epitectic concept or heterogeneous nucleation concept, also known as seeding agent. Here this theory says seeding agent include small foci of calcification that enlarge and coalesce, fuse to form calcified mass. Now come to the detail. First, how according to booster mechanism mineral precipitation occur, and this is occur by four methods. Mineral precipitation may be brought about in the following several ways. The first is the rise in the pH of the saliva causes precipitation of calcium phosphate. When a rise in the pH of the saliva, there will be causes the precipitation of calcium phosphate salt by lowering the precipitation constant. The pH may be elevated by why this pH become increased due to loss of carbon dioxide and the formation of ammonia by dental plaque bacteria or by protein degradation during stagnation. This is the first method which explain the booster mechanism mineral precipitation. Second is the colloidal proteins. In saliva, bind calcium and phosphate ion and maintain a supersaturated solution with respect to calcium phosphate salt. With stagnation of saliva, colloids settle out and the supersaturated state is no longer maintained, leading to precipitation of calcium phosphate salt. Mean colloidal protein in saliva cause mineral precipitation because in saliva they bind calcium and phosphate ion and maintain a supersaturated solution with respect to calcium phosphate salt. With stagnation of saliva, colloids settle out and the supersaturated state is no longer maintained, leading to precipitation of calcium and phosphate. Next is the third method is the phosphatase. Phosphatase enzyme is liberated from dental plaque, desquamative epithelial cell or bacterial, precipitates calcium phosphate by hydrolyzing organic phosphate in saliva, thus increasing the concentration of pre-phosphate ions. Mean phosphatase hydrolyze the organic phosphates in saliva, thus increase the concentration of pre-phosphate ion which precipitate with the calcium to start mineralization. Next is the esterase. Esterase is another enzyme that is present in the cocci and filamentous organism, leukocytes, macrophage, and desquamative epithelial cell of dental plaque. Esterase may initiate calcification by hydrolyzing fatty esters into free fatty acids. The fatty acid form soaps with calcium and magnesium that are later converted into less soluble calcium phosphate salts. This is all about booster mechanism, how mineral precipitation occur due to rise in the pH, due to colloidal protein, due to phosphatase, and due to esterase enzymes. Now come to the second theory, which is the epitectic concept or heterogeneous nucleation concept here, or seeding agent. And here seeding agent induce small foci of calcification that enlarge and coalesce to form a calcified mass. This concept has been referred to as the epitectic concept, or more appropriately heterogeneous nucleation, means different types of small nuclei make to form a large nuclei. The seeding agents in calculus formation are not known, but it is suspected that the intercellular matrix of plaque play an important role. Mean the intercellular matrix between cell, the matrix which are present a plaque, they act as a seeding agent and they make a nuclei. These nuclei fuse different nuclei to form a these nuclei make a to form a calcified mass. The carbohydrate and protein complexes may initiate calcification by removing calcium from saliva, which is known as chelation, and binding with it to form nuclei that induce subsequent deposition of minerals. This is the second epitectic theory. The seeding agent is intercellular matrix, and next is the carbohydrate protein complexes remove the calcium from saliva and they bind with the calcium to induce subsequent deposition of minerals. The third theory is the inhibition theory. This inhibition theory states pyrophosphate actually inhibit the calcification, but when pyrophosphate are absent, in the result there will be calcification. In inhibition theory, calcification occurring only at specific site is because of the existence of an inhibiting mechanism and non-calcifying site. Mean calcification occur only at specific site, not at all site. Why? Because at all site there is a inhibiting mechanism which inhibit the calcification. Where calcification occur, the inhibitor is apparently altered or removed. Inhibiting substance is thought to be pyrophosphate, very, very important for MCQs. And among the controlling mechanism is the enzyme alkaline phosphatase, which can hydrolyze the pyrophosphate to phosphate. The pyrophosphate inhibit calcification by preventing the initial nucleus from growing, possible by poisoning the growth center of the crystal. This poisoning is very important. How pyrophosphate inhibit calcification? By poisoning the growth center of the crystal. When there is no growth center, there will be no crystal. Now come to the fourth theory, which is the transformation theory. It says the amorphous non-crystalline deposit and brushite can change to octacalcium phosphate and then to hydroxyapatite crystal. In the result, there will be mineralization. Transformation theory says amorphous non-crystalline deposit and bruchite can be transformed to octacalcium phosphate and then to hydroxyapatite. It has been suggested that the controlling mechanism may be pyrophosphate. Again, they control this mechanism also, which prevent transformation. Hydroxyapatite need not arise exclusively via epitaxy and nucleation. Means hydroxyapatite need not arise exclusively via epitaxy and nucleation. Now come to the next is the after theories of mineralization, next come to the detection of calculus. How we detect calculus? First, detection of calculus, we detect calculus by three methods. Number one is a visual examination by use of compressed air. Second is probing, and third is radiograph. How? First is a visual examination by use of compressed air. In visual examination, we use ear to this compressed air, like in dental unit, we place on the gingival crevice, which retract the gingival crevice and tell about and make visibility to subgingival calculus, because gingival crevice they separate the gingival crevice from the teeth, and that below the subgingival calculus will be visible. This is the visual examination by use of compressed air in dental syringe, like in dental two-way syringe or three-way syringe in dental unit. Second is the probing. In probing, with the help of probe, again we detect the supra and subgingival calculus. Third is the radiograph. In radiograph, again there will be the radiopaque areas will be present. Now come to the these are the commonly used technique, these three. Next is the advanced technique. Now the advanced technique are there to detect calculus. These are the two methods in advanced technique, two system. Number one is the calculus detection system. They only detect. Second is the calculus detection and removal system. They can detect and remove also. In calculus detection system, first is the perioscopy. Perioscopy is actually a modification of endoscope. Like we do endoscopy of the stomach, here the perioscopy is the modification of endoscope, and this perioscopy tell the calculus picture on monitor, like in endoscopy of the stomach. Second is the detector, and detector is a in detector we use a diode, and this diode and this diode and fibro optic mechanism again tell about calculus. Second is the dignodent. In dignodent, we use a fluorescence mechanism, and the fluorescence of tooth surface, calculus and bone are different. They tell about, because there is a difference in fluorescence of the calculus from the teeth. These are the calculus detection system. Second is the calculus detection and removal system. They can detect and remove. Again, the first is the perioscopy. They can detect and remove, removal system. Second is the key laser. In key laser, again we use a LED light emitting diode. Here again we use a diode. Now, what is the difference between detector and key laser? In detector, we use a LED light emitting diode and fiber optic. Here in key laser, we use different types of diode combination, but key laser is the latest method, and key laser is the most expensive and costly method. These are the advanced technique, calculus detection system, and calculus detection and removal system. Sorry, man. Next is the now come to the last part, which is the anti-calculus agent. These are the agents which prevent calculus. Anti-calculus agent, we classify anti-calculus agent into first generation and second generation. In first generation, there are 4 types. First is a dissolution, which will dissolve the calculus. And in dissolution, there is the acids and sodium recinoleate. These are the these names are very, very important. Second is a plaque attachment. This agent will prevent the plaque attachment. Here the silicones ion exchange resin come in this first generation type plaque attachment, which prevent plaque attachment. These are the silicones and ion exchange resin. Third is the plaque inhibitions. They prevent the plaque formation, which are the antibiotics. And fourth is the matrix distribution. These are the enzymes. The matrix distribution, as we know, in seeding mechanism, the seeding foci are the intercellular matrix which form a calculi. But this matrix distribution, they prevent the intermatrix formation, intercellular matrix to act as a seeding agent. In matrix disruption, they disrupt the matrix. They prevent the organization of the matrix. In matrix disruption agent, there is an enzyme and 30% urea. Now come to the anti-calculus agent second generation. In second generation, they inhibit the crystals formation. Here is the vitamin C, pyrophosphate, diphosphonates, zinc salt, and calcium lactate. These are the second generation which prevent the crystal, which inhibit the crystal formation. Now, lastly, the most 3 important anti-calculus agent for MCQs is the triclosan, pyrophosphate, and zinc ions. This is all about calculus. Now today our 9th chapter, which is calculus, is complete. In next video we will discuss about next topic. Now if you like my video, press the like button and share this video with your friends. If you are new to my channel, subscribe my channel by pressing the red subscribe button, and also press the bell icon in order to receive my each new video notification. For watching my videos, I am very thankful to you. Thank you very much.